Hello? Hello? Okay, I'm just checking my audio. Sorry about that. I had to cut the video. I'm having audio issues. Let's see if I'm still having those same issues. Okay, I think we're good. Okay, so what's going on? We're trying to describe different kinds of solutions to our problems, ways of writing our solutions, and I went through going back and forth between interval notation and the drawing on the number line and the set builder notation. Now we're dealing with what happens when you have two intervals and you're kind of smushing them together or what have you. So the way we're going to approach these is by drawing three separate number lines, or this is the way I do it, and then shade in the intervals on the number lines, and you want them to be kind of connected to each other. So let's say -5, -4, 3, 2, and 1, 0, 1, 2, and I got the same tick marks right here. I have the same numbers on them, and then we'll put the intersection down here. Okay, so that symbol means intersection. And also, so that interval and the other interval. So you think of them as being kind of overlapping. It's kind of another word for it. So anyways, graphing -4 to 0 looks like this. Okay. Graphing -2 to 1. So I start at -2 and then I go all the way up to 1. And then you're looking for the overlapping region, right? So it kind of looks like it's right here. And so you're going to shade that in on this interval here. Right here. And then you have to ask yourself, do I include the endpoints, right? So to include the endpoints, that endpoint has to be in both the intervals. So -2, which is on the left here, is in both intervals, right? It's included in, well, it's really in the mix in the first on the first number line, and then it's included as an endpoint on the second number line. So we include it in our final answer, right? So we're going to have a bracket -2, and then we go all the way up to -1, 0. Okay, and do we include that? Well, this time it's in the second interval. It's within that interval, so it's definitely in the interval from -2 to 1, but it's not in the interval from -4 to 0. Okay, so we can't include that in the intersection. It would have to be in both for it to be included. So we'll have to use a parentheses on the other endpoint. Okay. Okay, so that's the intersection. Union is basically everything is included. So if it's in one or the other, it's going to be in the union. So let's look at one of those examples. And I approach it the same way. I'm going to draw three number lines. So here we're going -infinity to the 5, union with 1 to 8. Okay, so this symbol is the union symbol. And or is kind of the way you think of it. It's in one or the other, right? All right, so let's get our number lines going. Okay, so three number lines. First one is for -infinity to 5. Second one is for 1 to infinity, and then the third one is the union. Okay, I want the kind of numbers to line up. 1, 2, 3, 4, 5, 6. Okay. 2, 3, 4, 5. Okay. And then down here. Okay, so drawing in then negative infinity to 5. It's basically every number less than 5 but not equal to 5. 1 to infinity, so close bracket at 1 and then everything above it. Okay, and then it looks like pretty much everything goes. What did I screw something up? That shouldn't be, sorry, I did screw something up. I copied it off my notes wrong. This should be an 8. Sorry. So that's going to screw things up a little bit. You have to erase. Okay, back to work. 6, 7, 8. I'm gonna have to smush some extra tick marks in there for me. Here's 8. So it's going all the way up to 8. So there's our interval. Okay. So for unions, if it's in one, if the number is in one or the other or both, it's going to be in the union. Okay, so we're going to have everything from negative infinity to 5. And then on top of that, we have that other interval. So it's going from like 1 to, and because it's in, it's in both, it's in the union. So, and then we're going all the way up to 8. Okay. And the only question is is 8 included? Well, 8 is not in either interval. It has to be in one or the other. In this case, 8 is not in either. So on the second number line there from 1 to 8, you see it's not included there. It's also not included in the first interval at all. Just totally misses it. So in our case, we're not going to then include 8. And so the union of those two intervals is going to be from negative infinity to 8. Okay, so now we're able to describe the solutions to our inequalities, hopefully. In general, we'll just, we won't worry too much about kind of simplifying the union, but let's take a look. Okay, let's not get ahead of ourselves. One thing at a time. Okay, so solving linear equations. Okay, so this is almost exactly the same as solving linear, not equations, inequalities, right? We already did. But my point is we've already done linear equations. Linear inequalities are not that much different. There's just that one exception, right? So for example, if I have negative 3x plus 2 less than 7, to solve it, I just kind of work the same way I do with equations. I'm going to subtract the 2 over and try to isolate the x, right? Then I can divide by negative 3 on both sides, and that's where I get into trouble. If you divide or multiply by a negative, you have to change the direction of the inequality. Okay, so that's the big difference. So let me write that down. If you multiply or divide by a negative, you must change the direction of the inequality. Okay, so just be careful. Let's write this answer in our interval notation. If you need to do a number line in the beginning, that's fine. Generally, you don't have to, though. So here we have negative 5/3. This is x greater than that. So it's everything above it, but not equal to it. So it's this interval here. And then we can translate that into interval notation, which is my expression of choice, my so infinity. I don't really use the set builder notation. I like the interval notation, but you could use a set builder if you like. Okay, so that, if you wanted set builder, it would be the set of all x such that x is greater than negative 5/3. Oh, there we go. Okay. Let's look at a little bit of a harder one then. 4 times x plus 1 plus 2 greater than or equal to 3x plus 6. Distribute. Come combine like terms. Move the x's to one side. Isolate the variable. And finally, write up your solution set. Everything greater than 0. Okay, or if you wish. Okay, look, it's a little more difficult there. The next thing on the docket, compound inequalities. So basically you're doing two inequalities at once. Compound inequalities. For example, here we have 3 less than or equal to 4x minus 3, which is less than 19. Okay. What does this mean? It means two things. It means 3 less than or equal to 4x minus 3, and 4x minus 3 is less than 19. So you could work with them separately and kind of see what happens, but it's easier to just work with them all at once. Okay, so in other words, I can add 3 to isolate the variable in between, but if you add 3, you have to do all 3 sides. Okay. So you'll have 6 less than or equal to 4x less than 22. I mean, you could do the same thing over on the right. You know, add 3 to both sides, you end up with 6 less than or equal to 4x, and 4x less than 22. But this expression is equivalent to that expression. So why bother separating? Let's just kill all the birds with one stone. Okay, then we can isolate the variable, dividing everything by 4. So we get 3 halves less than or equal to x less than 11 halves. And unless I screwed something up, I feel like I screwed something up. Yeah, there's just a problem in my notes. Yeah, I just screwed up my notes. I think that's right. So on the number line, 3 halves is down here somewhere. 11 halves is greater than that. And we want everything in between, but not including 11 halves. So solution, 3 halves to 11 halves. Okay. And set builder notation if you wish. X such that x is greater than or equal to 3 halves, but less than 11 halves. Okay. It can be weird when you have like a negative in between. So another example, maybe you have 2 less than 3 minus x less than 5. Okay. And you add, you subtract 3. And then you get scared, right? What the heck do I do now? Because, we have that technicality. If you multiply, they're at the top of the screen. If you multiply or divide by a negative, you got to change the direction of the inequality. So how much does that really screw things up, If you get scared, you can break it down into its fundamental, form. So you have -1 less than negative x, and negative x less than 2. And if you multiply both sides, you get 1 greater than x, and x less than 2. And then if you put that together, what do we have? I have x less than 2. Oh, did I screw that up? I got to change the direction on that second. So sorry. Yeah, sorry. So what happens is we have x is less than 1. That's from this part. And then we have, but x is greater than -2. So then we get the bottom part. And how do we do that, all at once? Well, it's kind of easy. You just multiply all 3 sides. So going back to the left expression over here, you just multiply all 3 sides by -1, but you have to reverse the inequality. So you have 1 greater than x greater than -2. And then if you rewrite it in an ascending form, so you want the smaller numbers on the left, just like the number line. You would have -2. So I'm reading it backwards. I'm reading in this direction. -2 less than x. Okay, see that? Less than x. And then that's less than 1. And you see, you get the same thing you could have gotten if you did it separately. Okay, so if you multiply all three sides by a negative, you have to change the direction of both inequalities, is what I'm getting at. Okay, so you just flip both of them. Okay, let's move on. To absolute value inequalities. Okay, and there's two forms, or two types basically. And the first type, you have the absolute value of like u, which could be any algebraic expression greater than c. To solve it, you're going to split it into two inequalities. You're going to say, hey, that means u is less than -c, or u is greater than c. And then you solve those. Okay? The other type is this one. And it could be less than or equal to. It doesn't have to be just strictly less than. When you see these, you're going to turn it into a compound inequality. It's really an and case, but we're just going to write it as the compound, right? So you're going to go u less than c and greater than -c. Okay. You got to do it again by first isolating. So must first isolate the inequality. Okay. And again, it's one of these order things. You have to put on your socks first and then your shoes. You can't put your shoes on first and then your socks. Okay, it don't work. So please, please, please follow directions. Okay, so an example. And we have 3 times the absolute value of x minus 2 plus 5 is, I don't know, less than, make sure this works. 14. Right? Okay, so first isolate the absolute value. So move the 5. Divide by 3. And then you could do the compound inequality. So x minus 2 less than 3 but greater than -3. And you add 2 to all three sides. So you get -1 less than x less than 5. Okay, interval notation, -1 to 5. Okay. All right, let's do kind of the same thing, but with the other kind of inequality. So let's say 2 times x minus 5 minus 3 greater than or equal to, let's see what we want. How about 7? Okay. So again, you have to isolate the absolute value. Okay, so 2 absolute value x minus 5 greater than or equal to 10, and then divide both sides by 2. 5. And then you could split it up into your two your two inequalities. So x minus 5 less than or equal to -5, or x minus 5 greater than or equal to 5. And so here I add 5 to both sides, x less than or equal to 0, or here I add x greater than or equal to 10. Okay. On the number line, these are two separate intervals, and to get kind of our answer, it's a union. Okay. You see that word "or"? That means we're taking a union. Okay, so I know I noted that. Yeah, here it is. U for union. U for or. Okay. So when I write out my answer, you can do the 3 inequality things if you want. So here's 0 to infinity. Oh, less than 0, sorry. So of that. So here we have 0 and everything less than that, and then here it's 10 and everything greater than that. So the union is everything. So we need everything less than or equal to 0, everything greater than 10. And so our solution will be negative infinity to 0, unioned with 10 to infinity. Okay. Okay. So you see the word or, you're using union. Let's look at some harder ones that have maybe some fractions. Here's 66. Absolute value of 3 times x minus 1 all over 4, which is less than 6. So I have the less than symbol. That means I can do a compound inequality. To get rid of the 4, you can multiply all 3 sides by 4 if you want. Okay? Or you can kill both birds with one stone. You can multiply by 4/3. Okay. 4/3 times 6, 3 goes into 6 2 times. 2 times -4 is -8. 4/3 and the 3/4 cancel, x minus 1. Over here, you get 8 again, I think. Yeah. Okay. Add 1 to all 3 sides, and you got your answer. Okay. Let's look at the other version. So this time, we split it into 2 parts. Okay, so or multiply both sides by 4 for the first one. Okay, so you get 2x plus 2 less than or equal to -8. Add, subtract 2 from both sides, and then divide by 2 on both sides. For the right one, multiply by 4. Subtract 2. Divide by 2. Okay. And then we write up our solutions. You know, it's going to be everything less than or equal to -5, or anything that's greater than or equal to 2. Okay, so we use a union symbol for this, negative infinity to -5, bracket, union with 2 to infinity. Okay. Be aware that sometimes there are this type of problem. Okay, so what's going on here? I take 2x plus 3 less than -5. Well, sorry, this isn't an issue. I guess it doesn't. Okay, so this one, let's take a look. So you got 2x plus 3 less than -5 greater than +5. I mean, is there anything that's greater than 5? So let's look at that interval, you know. Here's 5, -5, and here is +5. So this expression is looking for things. Let's make it even, you know, more clear. So if I subtract 3, it's going to be -8. Over here, subtract 3, it's 2. Divide by 2. And you're looking for numbers in between -8 and 1. Okay. So you need numbers, rather, that are greater than 1 and less than -8. Okay? So you need a number that's in this interval and in this interval. Okay? There are no numbers that are in that. So what I'm trying to get at is just be, always keep kind of your pulse on reality, so to speak. In this case, there's no solutions to that inequality. It's just never going to be the case that that thing is less than, originally less than -3 because of this absolute value. It's always going to be something positive. If you put in an x value, the entire 2x plus 3 thing, once you take the absolute value of it, is going to be a positive thing. And then you're adding it to 2, which is also positive. A positive plus a positive is positive. It's always going to be greater than 0. It's never going to be less than -3. Okay, so just be careful. I'm not sure if the software pulls that on you at any time. But if you're kicking around a problem and you're kind of thinking, I have no clue what I did wrong, you may just want to try no solutions and see if that's the issue. Okay, we'll kind of leave it at there. As usual, you have problems, questions, come into my office hours. I think the Learning Center is online now. You can kind of go in there and work with a tutor there, but I'm not sure. You can email me and ask about it, and I can kind of poke around and figure out, what you need to go. Again, there's a lot of homework problems. Let's do one more. I feel like we need to do hundreds and hundreds of problems, but you can always fast forward or just pause the video. So this one doesn't look normal. Doesn't look like it's written in our appropriate form. And if you want to, you can rewrite it, right? You can flip the sides, but just make sure that you also flip the inequality. So you can rewrite it 11, absolute value 11 minus x, but it's not greater than 2. It's less than 2, right? So if you're reading in this direction, you have to go absolute value 11 minus x less than 2. Okay? And then you see it's the compound inequality form, greater than -2. And then you can subtract 11. -9. And then to get rid of that negative, you got to multiply by -1 on all three. But if you do that, you have to flip both inequalities. Okay. And then we like to write it in increasing, the same order as like on the number line. So 9 is before 13. So it's x greater than 9, but less than 13. It's that interval right there that we really want. So you would never write it with those inequalities in that direction, with the numbers kind of backwards. You need to kind of rewrite it. So 9 is less than x is less than 13. Okay, they're equivalent, but this version that I'm putting in the box here now, this version is the appropriate way to write it. It would be like speaking English backwards if you wrote it like this. Okay, that's backwards. You always want to put it in ascending order. Okay. I mean, I'd understand what you wrote, but it would be a headache. You're going to have to put some effort in, and so people understand what you're talking about, so people can appreciate your work. All right, so we'll leave it at that. As usual, you got a ton of homework in there. Get it done, and we'll see you next time.